Okay, so let's do some polynomial multiplication. So we've gone over box method very in depth at the beginning of the year. We went through box method and how to factor using, an area model, box method. So I'm not going to use distribution method here to multiply this, and that's because this is a trinomial times a trinomial. So you see that this is a trinomial times a trinomial. So that means I'm going to have 9 terms. I'd much rather just use box method, keep it all organized, use my diagonals as the like terms, and I think it's just smoother. If you like to do it distribution method, that's totally fine. The reason I'm going over multiplication again is because I think a lot of us were confused when we were asked in function notation. So if my first polynomial on top, if I call that f of x, and the one on the bottom, if I call that g of x, and I ask you to multiply f of x times g of x, I am literally just asking you to do this multiplication right here. I'm asking you to multiply those two polynomials. I'm asking you to multiply those two polynomials so that we can get an answer for what the multiplication of those two polynomials is. So let's just not get caught up on the fact that we're calling them f of x, g of x, h of x, r of x, s of x, all of those different things. That's just the name of the function. So let me stop talking and let's actually start multiplying. So 4x squared times x squared. Well, that's 4 times 1, which is 4, and then we multiply the variables x squared times x squared. When we multiply the variables, remember, we're adding the exponent. So 2 plus 2 gives me 4. And then I'm just going to go to the right across the row. 2 times 4 is 8. Oops, I hit the erase button. 2 times 4 is 8. And x squared times x is going to give us x to the third power, because remember, this has a power of 1. Okay? Now I'm going to do 4x squared times 3, my constant, so that's just going to give me 12x squared. Then I'm going to move down to negative 8x. Negative 8x times 1 gives us negative 8. X times x squared gives us x cubed. Negative 8 times 2 gives us negative 16, and x times x gives us x squared. Finally, I have negative 8x times my constant, which gives me a negative 24x. And the last row is actually pretty simple because they're being multiplied by 1. So 1 times anything is itself. So x squared times 1 is x squared. 2x times 1 is 2x. And 3 times 1 is 3. So I just did the bulk of the work. I'm not quite done yet. Now I need to combine like terms. So I want to combine these like terms here and these like terms here. Notice that both of those are x cubed. All 3 of these are x squared. And then here they're linear. We have just x. So those are our like terms. So let's take it out and combine. So I have 4x to the 4th. So I'm just looking at what's happening here. Negative 8x cubed plus 8x cubed is just 0x cubed. So that's just 0, right? It's just 0. In this second line of the diagonal, I have x squared, negative 16x squared, and 12x squared. So that gives me a positive 13x squared minus 16x squared. So this is going to be a negative 3x squared. And you can put this in your calculator. 1 minus 16 plus 12, it will be negative 3. Next one, we have 2 minus 24. That's going to give us a negative 22x. And then plus 3. And that is our final answer. And I think you'll find using box method is just way faster than doing this using distribution method. But again, to each their own. You should get the same exact answer if you do it the other way. The main takeaway here is that when you're doing the multiplication, you're not getting confused by f of x times g of x. You're understanding that f of x is represented by this function and g of x is represented by this function, and you're multiplying those two together to get the product or the answer. All right, so check back for another video to further go into multiplying with function notation.